Okay, just a reminder of how to use these video clips. They're not designed to be mark schemes, so I'm not going to tell you every possible answer, every possible correct answer, but what I am trying to do is teach you the best answer on good physics. Okay, so question 3. Which letter represents the angle of refraction? Okay, if we look here, as the ray goes from the low optical density air into the high optical density glass, it gets refracted towards the normal. Okay, so that's narrowed it down to these two angles. Okay, and the angle of refraction is always measured between the normal, okay, and the ray. So that one's D. Explain how the student can use the glass block to find an accurate value of the refractive index of glass. Okay, so first of all we need to know this equation, that n, the refractive index of the glass, is equal to sine I over sine R. Okay, so the first thing that you're going to need to do is vary I and then measure I and R. And of course the thing that we use to measure angles is a protractor, so you need to say that as well. Okay, the next step is that you need to plot a graph. Okay, now you could, after you'd measured the angle, you could just calculate sine I and sine R for each value and calculate n that way using a calculator. Okay, but that wouldn't give you the maximum marks for this question. Okay, because that's not the best technique. Okay, that doesn't give you a weighted average of which point's the strongest and closest to the line, stuff like that. So you're going to plot a graph of sine R on the x-axis and sine I on the y-axis. Okay, and you'd end up with your points on the graph like this. Okay, and then you'd plot the line of best fit. Okay, and then that's giving you a weighted average for all of the results of your experiment. Okay, so how do you find n from that? You'll remember this formula from your maths lessons. The gradient is the rise, the change in y, over the run, the change in x. Now if we look at what we've got in our equation, on the x-axis we've got sine R, and on the y-axis we've got sine I. So if you substitute those into our equation, now we've got the gradient is equal to sine I over sine R. But if you compare it to this equation up at the top, you'll see that that's just n, the refractive index. Okay, so to access full marks for this question, you need to say that you're going to plot a graph of sine R on the x-axis, sine I on the y-axis, take the gradient of the graph, and then that will give you the refractive index n.